Good to go now.
ఇది ప్రాబ్లం. యాక్చువల్లీ హాఫ్ ప్రాబ్లమ్ తీసుకున్నప్పుడు ఇక్కడ స్ట్రక్ట్ ఇచ్చాము. ఇది
Mhm.
ఇన్ కేస్ సిమెట్రీ కాకపోతే ఎలా అని. ఇప్పుడు వన్ సైడ్ స్ట్రట్టింగ్ ఇచ్చి ఈక్వివాలెంట్ లెంత్ 30 ప్రొవైడ్ చేయొచ్చా? ఈ స్పేసింగ్ 30 మీటర్స్ అయితే?
And see, ఇప్పుడు actually you have to understand the important. Yeah, maybe Vivek is also there. We'll go with English.
ఓకే. ఓకే.
Okay. See, when this particular geometry is same, that means same in a sense. I can say that if you cut exactly at the middle, this side also you are considering the same site space, and this side also if you are considering the same site area, then what you need to do, instead of building up the whole thing, that we can just go as a symmetric model.
Yeah, but suppose I have
Yeah,
a
suppose
restriction
here,
along one side.
yeah. Maybe on the left hand side you have a something, on the right hand side you have a different thing.
Yes.
On the left hand side the loads are different, on the right hand side the loads are different. So in this particular cases, it is suggestible to go with the full model as what you did right now.
Yeah. But
Okay.
so
In
far
this
I have
actually,
no
yeah,
confusion here.
yeah. In this, if you would like to go for this particular structure, actually what you have built.
Yeah.
So realistically, if you see that, forget about the software for a while, go to your site, imagine that after installing the sheet piles that you have excavated up to a certain level, and then you realize that you want to build a support between these two walls, right?
Yeah.
That is
But if
what is the main purpose of the strut is to support these two particular walls.
um actually I have done a lot of shoring works.
Okay.
But if the depth of excavation is more, that means
Hmm.
the retention.
Hmm. Hmm.
If our sheet piling length is restrictable, then in that case, that strutting is necessary.
Yes.
Yeah.
Just to why strutting is going, just to avoid the deflections of your sheet piles.
Yeah.
Excuse me. Yeah. Okay. Just to avoid this particular restriction. So
Yeah.
to realistically, that is connected from this end to that end. Full length it is going to be connected, right?
Yeah.
So in software, if you are going for symmetry model, you can't do the full length, right?
In case of
So you
symmetry.
can't do the full length, right? So you can't do the full length if you go for a symmetry. So in that particular cases, your fixed end anchors will support you.
Yeah.
But when you are going with the model, I always suggested do a line and convert that particular line as a plate element. And to that particular plate element, you can start assigning the fixed and anchor material properties.
Okay. What about that end conditions? Is that both are similar?
Yeah, both are similar only.
Okay.
That realistically how we are going it. So based upon that also you can able to change it. If you want both are like similar, that if you would like to put it there, then you can go in that particular way. Or else one side if it is fixed and the other side you want to move it as a joint connection, that is also possible.
Can you explain that case
Yeah,
anytime?
let me do. I will make you to do from your side itself so that you will get confident. Now zoom that
You
region.
you may take my control of this one.
Yeah. Can
Can
you give
I
me
give any
any
desk?
desk? Okay. But you can give me the control in Teams also, right?
How I don't know.
While sharing your screen, that you will get an option at the top, give control. Okay, anyways, AnyDesk is not installed. I need to install it now.
Okay. In this case, by using this, how can I give control?
There is an option actually. As you are sharing the screen, that you can able to. give the control to
Can
me.
I?
1 second. Okay, I'll just show you an example so that you can do that. Okay.
Okay.
Let me
Can I
share
stop
my.
sharing?
Yeah, I know. I will share my screen. So let me know if you can see my screen.
Yeah, I'm seeing.
Okay, fine. Yeah. So if you see this, you can see the Plaxis window also, right?
Yeah.
Okay, fine. Yeah. As this is a symmetric model, here actually what I did, I just simply went with the fixed end anchor.
Yeah.
So onto this particular fixed end anchor, I've just assigned this particular material properties.
Yeah.
And if you just see this, the direction X side, I have given a length of a 15 meters. That means the meaning here is like up to this is 15 meters. After that, another 15 meters is that. Anyways, that's going to be the geometrical symmetry. I'm going to solve only the half. So I'm just considering the 15 meters. Now, in this particular 15 meters of a length, that is what actually you are telling that it is an equivalent length of 15 meters. And you are telling that it is going in the direction of a X direction.
Yeah.
Okay. Suppose, let's say that your geometry is not symmetry in conditions. So in that particular cases, you are not supposed to use this particular fixed end anchors. You can use, I mean, uh, there is a flexibility where you can just go to the thing. So you can just go create a line. So maybe just below, I'm just doing this. So you can create, it's not to create, it's not to object. Just you are taking at the same length. So you're just going for this one. Now actually it is clear that so 19 minus like 50. This is the coordinate values that we were just going with 50 and 19 for that particular point. And if you just expand this one, yeah, if you just expand this particular things and all, so X is like 65. That is from starting from 50 point. So that we will just come to know that is a 15 meters length of line. And this particular line you can right click, create, and now what are the best possibilities you can create is like you can create as a plate element. Okay, so you can just create this as a plate element, and then or you can just go it as an anchor also instead of a fixed end anchors. That if you really wanted to go for the anchor definition itself, you can just click it as a node to node and anchors and all. So now actually the behavior it has been changed from node to node and anchors, and then you can able to assign the material properties also. Now the material properties is the strut material properties are not assigning to this one. So previously see this one, the material properties of this and the material properties of this actually. Yeah. So this is where actually you can able to do this. So this is a fixed end anchors. So the meaning itself, it is telling that both the sides are like a fixed in conditions. So that's why we are naming this as a fixed end anchors and all. But suppose you are not creating a fixed end anchors, but if you would like to create this as a plate element, instead of fixed end anchors, you can just go and create this as a plate element. Now, if you create this particular plate element, so you have a control, like select this particular plate element. Okay. No, this is not a node to node anchor, so you have to create this as a plate. It's okay, incompatible. So I somehow I just need to delete and then so what we can do, we can consider this particular line itself. Right click here, create this as a plate element. Now, after creating this as a plate element, now you have a something like, you can just go over here and then you can able to choose this particular things as like a wall. So if you just go as a fixed end anchor, this particular end and this particular end are fixed. And if you just go it as a wall, so I mean as a plate element, even this end and this end also, that you don't have any control over there. But if you really control it, it is not logically correct, but actually physically it is correct. So for that, actually you can just go create a one more line. Okay, so in this line, actually right click here, create. So if you just see all the best possibilities that you are seeing, right? So now you can just make it as an embedded beam element and all, actually embedded beam row. Okay, so if you just make this as an embedded beam row, what happens, it is physically it is correct, but logically it is not correct. Okay, it is well acting like a row element. So now you can just go and assign your embedded beam material properties. Okay, and the behavior of this is either a pile, or you would like to see it as a grout body or the rock bolt. So make it, if you go for a grout body, it is almost all similar to that of your fixed end anchors. But if you just go for it as like a rock bolt, then you can able to say that the connection point, the first point, that which one you would like to see this connection you want to fix, and what kind of a connection that was, hinged or like a free connection. So one end is completely fixed and the other end that you have a control over here. So this is where that you have to. So the three different varieties I have shown. The fixed end anchor is this one, which logically and physically makes sense. And the other plate element also, it logically makes sense because it's nearer to that of your fixed end anchors only. And the other one is like an embedded beam rows. So in the embedded beam rows, actually, you have a control onto the points, but this is logically, don't consider this one because this is not correct one. So but actually physically, that if you want to do these kind of things, that is also possible. That is what I mean to say.
Okay.
Got it? Now how to
Okay.
control that one? So this is how you can just able to control that particular things and all.
Okay.
Any other doubts, Bharat?
No.
This
That
problem makes you comfortable. Now you are feeling good for browsing Plaxis and doing some activities, creating
yeah.
soils.
Yeah.
Okay, so but
Yeah.
don't do any operation blindly. If you got a doubt why I need to draw a line here, you should have a logic with you.
Yeah. Okay.
Okay. Yeah. How is going on with Vivek and Ashok?
Sorry. Okay. I have practiced this assignment.
Okay, fine. You're feeling
Hello.
comfortable?
Yes.
See, my main agenda till now is like I want to make you comfortable with Plaxis. Okay, so if you are comfortable with Plaxis doing up these things, you know how to create a boreholes. Now I can say that you know everything. You know everything, but when to use which thing is what that will come from the practice. And for that particular practice only, we are going to do the more and more examples. That's it. So feel free to download the technical papers, start doing on those particular things and all, and come back with some solutions on that. Yeah.
Okay.
Now,
Hello. Hello,
yeah,
bro.
yeah, Bharat.
Still I have doubts. Can I share
Yeah,
my
yeah. Okay,
screen?
okay. Yeah, please.
In that time, you have said this interaction, positive, negative interface, the
Yeah.
direction should be.
Hmm, hmm, hmm.
But as per the document which you have provided, in that document itself, they had given one note, which is
Hmm.
whatever be the sign along left or right, there will be no.
No, I
Hmm?
also told no, it is just a meaning of a sign, that's it.
Yeah. Mm.
The functionality would be the same.
Okay. Here, in one case
what I
have
told is like in some of the papers, they might have shown that images in a different directions, but why you are not getting, you should not feel confused. So for that, I told you, if you draw a
Yeah.
line from top to your bottom, left-hand side is your negative interface, right-hand side is your positive interface. But if you draw a line from bottom to your top, then left-hand side will be your positive interface and right-hand side will be your negative interface.
Okay. If you see here, I have a load advancement procedure fails
Mhm.
while
What was that
installing the.
step actually? What you have done over there?
Here I have installed strut. This case.
Okay, so can you click on the initial phase once?
In output
First, I
or
would
in.
like not in output actually. We can see
Okay.
here itself. Yeah, initial phase. Click on this.
In this
Okay.
case,
Next in the loading phase.
next to loading phase.
Loading phase. Click on the loading phase itself. Okay, you have a. No. Close this. Close this one. That is sufficient for me. Loading phase actually the line loads that you have activated, plates and all you have activated. See, when you activated the plates, so why didn't you activated the interfaces?
Here.
Yeah,
Okay.
activate the interfaces also.
Okay.
Okay, next click on that first excavation. So the first excavation, how much depth you are going?
I have some 1 meter. Randomly, I had went.
Okay,
This
but it
phase
is
also
successful. But it is running successfully.
Yeah.
Okay, fine.
Next, I have installed.
No. In this phase also, you have to activate the interfaces. So the line loads and then fixed and anchors, the plate elements. Okay, fine.
Next, I have went to another excavation. Here also, I need to activate.
You went to another excavation.
Yeah.
That's fine. Okay.
Next, I have given one strut, second strut.
Why you want to go with the second strut?
Just randomly, I have done.
Okay. So the second excavation, can you click on the second installation of the first strut once? Not this. Not. Yeah. There. Yeah. Installation of the first strut and that particular time. Yeah. Okay. Now go for the second excavation. Now click on the second strut installation. Plates. Can you expand the plates here in the below Model Explorer? Expand the plates. Not there, not there. That's a Selection Explorer. Model
Okay.
Explorer is about
Okay.
last one. Can you click on the first excavation first once? Plates are there. Click on the second strut installation. Okay, can you expand the fixed and anchors also? Now click on the first first strut installation once. Okay, fine. And what was the equivalent length of this that you have chosen?
15, 30 meters I had given.
See, 30 meters, one thing. When you are going the full geometry, you should not use this particular strut. Either you have to use this as a node to node and anchor. Instead of fixed and anchors, you have
not
to use a node to node and anchors.
Yeah, just what we have discussed today.
Yes.
Okay.
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 And Yeah, Bharat. Sorry, yeah, Vivek.
This strut is not fixed to another end, na? The strut he applied to left
Yeah,
side.
it was actually what happened, fixed end anchors, it is hanging onto the other side actually.
Yes,
As you are
exactly.
going with a full geometry, it is hanging. But previously, when you stop for the exact axis, your boundary conditions will take care of it. But now the boundary conditions is not applied, so it will be hanging. Yeah, that is what, just to make sure that I was looking into this. Now you can go to the results. Not calculate results.
You may see.
Yeah, your results. Okay, initial phase.
Loading.
Okay, it's all good.
There
Put
have been-
control 2, control 2. Okay. See, when you just installed it actually, now you can go and measure it. Actually, in this case, what you have to do, you have to get it out. As the geometry, everything is symmetry that you are feeling it. The deflection onto the left hand plate and to the deflections onto the right hand plate or sheet pile. Both the sheet piles should behave equally, right? It should be
Yeah.
symmetry in nature, right? So, but if you just go to the deflections or the displacement happen on any on the plates actually because of this. Okay, where you failed, you go. I'll show you there itself. Where you fail, you go to that particular step.
This is the case.
Now, what happened if you see this one? On the left hand side, it is very robust. So that's why there is a no deformations. But on the right hand side, there is a no support for that particular plate. That's why it is failing.
Yeah, that is what in WhatsApp I have given this fixed and anchor this side also. In that case, it will be passed. I have doubt on this one only.
Huh, you see, the meaning is like fixed and anchor is like the other side, it is hanging.
Yeah.
If it is a geometry, let me quickly share my screen so that you will get an idea. Let me know if you can see my screen. Can see, right?
Yeah.
Okay. So what happened, Okay, yeah. Now I have fixed up this here, fixed it up.
Okay.
This is good. This is good. And this particular plate is getting support and all. It's absolutely fine. And now if I just go for this, model conditions, deformations, if you see this deformations, now you can see this boundary conditions over here, boundary x minimum. So I know this is my x-axis, right? X minimum is this one, and the x maximum is this side. Y minimum is this one, and the y maximum is this one. Now, if you see this, what happened? X minimum and x maximum are normally fixed. That means in the vertical directions, these are all fixed in conditions. If you just go for this, even in the flow conditions or to the mesh or to the stage construction, the meshing, you just start viewing the mesh actually. Okay, geometry and fixities. If you see these particular fixities, what happened here? The geometry or the software is understanding that this particular boundary is fixed. Normally, it is fixed, and this side also the normally it is fixed. But in your case, what happened? This portion is not fixed. This where you have another plate element or something after this. so which doesn't have any particular boundary conditions. So that's why this particular type of anchors is not supported for you. You have to go with a node to node and anchors. But the other side, actually, it is already fixed. So that's why if I consider this the 15 meters of a length, so this it will be fixed it over here, and then it is going to take an image of it, right? So in that particular cases, the fixed and anchors will help you. But in the other cases where you don't have the fixity boundary conditions, your fixity boundary conditions is somewhere else over here, not to the exact point at which we needed over there. So in that particular cases, it's must and should that you have to consider the node to node and anchors. Now you got an idea why your node to node fixed and anchor, if you give, why it is hanging over there.
Yeah. Yeah.
Cool. Yeah. Any other doubts you have?
No, no. Bro.
Okay, fine. So I hope like you have a real site experience also, that it makes you more comfortable in this particular problem. So maybe whatever the challenges you faced in the real site, let's try to bring it here and try to work out on that. And if you have any soil samples also, that particular data also you provided,
Yeah.
and,
Okay.
and then try with this. I can tell you a scenarios actually. You have excavated certain length, but suddenly because of some budgetary issues or some X parameters, whatever it may be, the construction got delayed for 5 days. And in these 5 days, actually, you can see that there is a heavy rainfall. And because of this, actually, the excavation is completely filled up with water. And after few days, actually, I mean, with water, it is getting consolidated for 5 days. And on the sixth day, when you are trying to remove the water from that, how your soil behavior will be there in that particular point of time, really these struts will help you, or it is easy to install or it's hard to install. So such a kind of simulations you can start doing that.
Yeah. Okay.
Okay, one example I told you, but this many site examples might be there.
Yeah.
One normally common problem it was actually. So there might be a chances like there is a holidays, a festival holidays it is coming, but you have excavated it and then you left it over there. Unfortunately, it's environmental conditions we don't know. It might be a too sunny also. Because of this too much of sunny, the consolidation might have been happened very quickly. So that means the underground water has been drained and the pore pressure relief it happened. So because of that, actually the soil may get stronger and stronger. And because of that, actually, is there any possibility near to this installation cracks may form?
Yeah.
Okay, so you can just think of it and then try to work out to the best,
Okay.
like whatever you feel.
Another thing,
Hmm.
suppose I have to go without the strutting.
Mm-hmm.
How can I find based on deflection only? I can find the embedment of the sheet pile.
Yes. So if you don't want to go with the struts, then you have to increase the depth of sheet pile. So if you would like to increase the sheet pile depth, so first you have to study what is the deflection rate is coming.
Yeah.
So as you guys mentioned me already, it's a 5% or 8%. That depends
Yeah.
upon the company, it will decide it. So you can stick on to 1% and then identify that if that deviation it is coming, start increasing the depth. And then here actually a challenge will come. Increasing the depth and installation will be easy, or going installations of the pile sheet piles up to a certain length. After that, inserting the struts is very easy.
Mm.
Labor charges, environmental conditions, soil conditions, everything that you need to consider here.
Yeah.
Okay, it's not just about like stability, it's all about the money flow also.
Mm. Okay.
Okay, any other doubts in this example?
No.
Okay, fine then.
Okay.
So Let me take you to this. So submerged construction excavations that we were done. I think you're all good too as well. So now I would like to explain you the settlement of a tunnel actually. So this also, that's very interesting. You can see this one. So what happened here? Here also I'm just going with the symmetric model, but I always encourage you to go with a full model also. But in the diagram itself also they have given it as a symmetric model, and not an axis symmetry, it is geometrical symmetry. I have a deep sand, over that I have a deep clay, over that I have a sand, and then I have a clay materials. Okay, these are my soil materials, I have it. So, and each layer, what is the thickness also, that I have the information. And from the center point to the I can say the center point for the tunnel construction actually. I can say the center point for the tunnel construction. So to the tunnel constructions, the right hand side I have a half, and to the left hand side I might be having another half. But right now I'm simulating only the half of it. Okay, and after tunnel construction, there is up to a 5 meters of a length, there's already some kind of piles is being inserted. Over the piles, actually, there might be some 5-story building or a 10-story building which is already constructed. On that, which is already constructed, behind that, actually, you are trying to go with some kind of a tunnel is coming. So already a building is there and which is supported with the piles and all. Just behind this particular piles, if a tunnel it is coming, because of this particular tunnel, how actually this particular story of 5-story building or a 10-story building will affect. Okay, not during the tunneling process, but if tunnel is there, in that particular cases, what is the maximum deflections of a tunnel and to the building it can happen it, and based upon that, like we can able to go ahead like what would be the prefabricated plate thickness of my tunnel. So in this analysis this analysis will help you to analyze those particular cases and all. Okay, so it's as simple process as what we are doing it similar way, but only one particular new option that you're trying to learn is like how to create a tunnel and what are all the other properties of the tunnel that you are feeding it, everything that you can able to do it here. I'll show you that how to create a tunnel too as well now today. And then if you see this, after creating this, this is what actually you're getting it. And now phase one that you are doing the building construction. So the complete building load actually you are applying it onto the this particular plate element itself, or like to the plate itself, you can apply to that entire weight actually. Okay, so a simple thing that it has been done, and then we would like to see that conicity of this and void grouting of this particular things also. So how we are going to do that particular parts and all that we will see that, and then how we are going to do the lining installation of all these particular things that we will do it. So this is a little complicated one, I can say, but it is slowly understandable also. So we may take two different sessions for this too as well. So today I would like to make you more comfortable on creating a tunnel actually. Okay, so and then we will just go with what is the grouting process and concentration maintenance, how we are going to do that. All those things I'll explain you slowly on this. Now, when you just see this particular problem, I would like to create a tunnel, and to create this particular tunnel, actually, you have to go for structures. See, the tunnel license will not be available for all. Who comes under the VIP license, only those particular people can able to do the tunneling. So what do you mean by a VIP license is like a company purchases a Plaxis software. After first year or 2 years, they'll get a free maintenance cost. After that, you have to pay the maintenance cost. If you pay the maintenance cost, then only you will be a VIP customer. If you didn't pay the maintenance cost, then you will not be a VIP customer. So if you fall under VIP, there are special features that you can access it. But if you are not under VIP, you cannot able to access it. Just to maintain the business continuously. So this kind of a logics they were trying to implement it here. So now, if you would like to go for this, go to structures, Now on to the structures actually, you have an option to create a tunnel over here. So create a tunnel. So click on this particular create a tunnel and then choose the point like where you would like to add this particular tunnel and all. So I was just clicking on this particular point. So now once if I click on this, if you have a VIP license again, then only you can able to see this particular option. If you don't have the VIP license, you can't see that. Okay. So once if I click on this particular tunnel, now actually the shape type actually. So what kind of a shape that you would like to do, whether it's a free shape or okay. So those kind of things. So this particular tunneling option, again, it can be do using Python customization also. Though you are not a VIP customer, but still if you would like to integrate that particular option, there are the ways that we will support. Okay, so now you can go with the free or a circular one. So let's say I would like to go with a free. And are you going to define the whole tunnel or you're going to define only the right half or the left half? So let's say that I would like to define only the right half, and then it is a circle. Circular one, the right half. So this is what is the tunnel that I would like to construct it. And now offset being this. So this is my x-axis and this is my y-axis. So suppose if from y-axis I would like to offset a distance of 5 meters, then actually what happened? So now see these particular things on the y-axis, it has been deviated to the 5 meters amount. Okay. Suppose if you would like to deviate in this direction, then you can just go with like this. Okay. So from this point, actually, that you have been deviated for another 5 meters over there. Okay. Now I don't want any kind of a deviation. So that's why it is like I'm just going for 0, 0. Okay. And here, if you just clearly see these particular things in the tunnel as a separate module, you can say that you have an options like you're creating a cross section. Okay, in the cross section you have something called as a general. In the general you are choosing that it's a circular shape and it's a right half or the left half or it's a full circle, everything. And then you have an option called as a segments here. So if you just go for the segment, now if you just click on this particular segment, and that's where it will ask you like what is the radius of your tunnel. Okay, so my tunnel radius is something like 2.5 meters of a radius. So you can just provide the 2.5 meters of a radius actually. So this is how actually the radius it is going to be defined it actually. Okay, so that means now you can see that so the length between this and this 2.5 radius, right, that is 5 meters. Suppose instead of 2.5 meters, if you just go it is a 1. So if the radius is 1, so the diameter is 2. So it is where like delta 2 it is coming over there. Okay, so this is how actually you can able to define the radius of this and the start angle. So from where exactly that you would like to exactly at 0 or you would like to start at 45 degrees. This is how actually. So from this particular portion you are doing the half thing. No, I'm not doing with the 45 degrees. I would like to do it as a 90 degrees. Then this is where actually that you are trying to create the things and all. Not 180 degrees. I would like to go with the 180 degrees. So you have an option completely mirror of this. Okay, not 182 actually. I would like to go at a 0. So now this comes to your original place over here. Okay, so this is what actually you can able to decide the radius and from which directions that you would like to create the tunnel. Is that clear?
Yes.
Yeah.
Okay, fine. So once the segment is done, actually, you have to go for the subsections. So the subsections is something like you have a multiple options over here. So in the subsections that you would like to add something, you would like to insert it, or like based upon that, you can able to go for this particular things and all. Suppose if you would like to add a subsection, add it, and based on that if you would like to add some line or something like that, or if you would like to close this particular thing only half, so in that particular cases it will be helpful for you, but not in this. So I can delete this here. And if you go for the subsections, here you have a something called as an generate the thick lining and all. So you can able to decide this, what is the thickness of your tunnel that if you would like to go. So let's say like 0.2 meters of a thickness that I would like to go. Now with that particular thickness actually, it will go, and this particular thickness will be added into the outer side, not to the inner side. This particular thickness will be added to the outer side of it. Suppose if you don't want that particular things also, you can just delete this thing completely, no issues. But in this actually, so like this, you can able to create this particular segments over here. Okay, so you can just able to create this particular cross section. You can create the cross section. You can go with the segments, whatever you want to do, and you can able to add the subsections also if needed. And then one more thing, instead of cross sections, that you click on this properties. Now into the properties that you can able to go for the general. So this is where if you would like to add interfaces. Suppose you'd like to create a positive interface over here, and you would like to create a negative interface over here. You know that importance of this. Okay, so the positive and negative interfaces, the interactions to the soil that we are creating here. So this makes you like more comfortable again. So to study the results in deeper actually. So now once this is done here, now you can just go for the refinements, reinforcements actually. Sorry, it's not refinements, it's a reinforcements. So in the reinforcements actually, if you would like to insert any kind of a grouting, that means you have the prefabricated plates actually that you are bringing it, and you are putting it to the soil, applying some pressure, and if it would like to stick on that, you need to go for a grouting also. So for that particular thing, it is where you can able to define the groutings also. So click on this particular grouting, how many groutings that if you want it, you can able to create that number of groutings, and then you can able to go and define this particular position too as well. Okay, now this is where like we can just go ahead. Okay, now this is where like we can just able to create these particular things and all. And this is how actually the full thing. And now actually what you can do, you have an option here. Let me minimize this. You have an option called as a generate. So if you just click on this particular generate option and then close here, then automatically with all the dimensions onto the grouting, everything it has been created there. Okay, so it is being created in that particular ways. We can able to create this particular tunnel, and onto this actually, you know how to insert a pile, how to create a building, how to apply the load, and see what was the deflections on this. So even in the same example also, that they have done it everything, and finally they have observed the deflections are happening onto this. What is the deflection happened onto this particular tunnel? That is what actually they have been captured it actually. So will you be able to create a tunnel and test it? Maybe not with the same geometry and thing, but you can go ahead with anything, but create a simple tunnel, either it is a half tunnel or a full tunnel, anything is fine. Create your own tunnel and try to apply the load and see what is the deflections it is coming onto it. Will you be able to do that?
Yeah.
Okay.
Right.
Okay. Yeah. Now actually, if you just click on this thing, you have done it all these particular things, but you have not raised me a question. Like, Sai, that you have created a tunnel, it's all good, but what is the material properties of your lining thickness, or like what is the tunnel material properties that you are defining it? Okay, so to define a tunnel material properties, or if you would like to edit the tunnel again, so you just go here, click on it. You can't edit it actually. If you go any kind of an operations, that is quite difficult to go for this. So only option is like model explorer. You have to expand this tunnel one, right click here and go and edit this particular tunnel. After editing this, actually in this particular edit, you can able to see, go for the segments. This is the segment that you have created it, and this particular segment, sorry, the subsections, subsections. Oh, okay. The properties that you are creating, all this positive interface and the negative interfaces. Now in the same properties that you can able to go, you can right click here, create it as a plate element. Now create this as a plate element, and to this particular plate actually that you would like to apply the tunnel material properties. You have to apply the tunnel material properties, and then you have to generate and close this. Now actually the tunnel, it has been applied with material properties also. Apart from the interfaces and the lining thickness and all, it has been applied with the material properties also. Okay. So if you didn't assign the material properties, your problem will not solve. So make sure that here in 2D for the tunneling that you are creating it as a plate element and then you are assigning it. It makes sense for you all?
Yeah.
Okay,
Yeah.
fine. Okay, cool. So I don't want to disturb you much by providing a more information again. So try achieving this up to this, and then tomorrow when we are meeting it again, that we will work out further on that. How to construct that particular whole things, and then how to visualize the results, all those particular things. Tomorrow we will see that. Okay.